So the first experiment is calculation of y parameter to calculate and verify y parameter of a two-port network. Okay. Similarly, to calculate and verify ABCD parameters of a two-port network, right? So these two experiments we are going to perform today on LTSPICE. So your experiment number 7 to calculate and verify y parameters of a two-port network. Okay. So in this case, we have taken a very simple circuit. There is a resistance of 1 ohm, that is your R1, 2 ohm resistance, and there is a resistance of 3 ohm. So if you see here, we apply a voltage source here. So you have a voltage source here. That is V1, or you can give the value. This is equal to 5 volt. I1 is the current as a result of this. In the same manner, you can apply a source of voltage here. V2 and I2 is the current from this. Okay. Now, if you see here in the Y parameter, we say also use the term short circuit parameters. Okay, or short circuit admittance parameter. It is basically reciprocal of your impedance. Admittance is reciprocal of your impedance. So here, if you want to calculate, so you can easily calculate. If you see in this branch, I1 plus I2 is flowing because I1 is coming from this. So you can make your own, you can apply KVL in this case. And when you apply KVL, then I'm writing the direct result instead of solving this completely. You can say that your I1 will be what? 5 by 11 V1. I'm not putting the value of V1 5 volt and V2 4 volt as of now. Okay, no problem. Then this is minus 2 by 11 V2 and I2 is minus 2 by 11 V1 plus 3 by 11 V2. So if you see in Y parameters, if you remember, your I1 was what? Y11 V1 plus Y12 V2. In the same manner, I2 was, we were expressing the current in terms of input and output voltages. So here it is Y21 V1 plus Y22 V2. And when you equate these two equations, you will find you equate this with this and you equate this with this. So on equating or on comparing, you can say that your Y11 is 5 by 11 V1. Y12 is minus 2 by 11. I'm not going how we solve this because how we will solve this because already we have covered this topic in the module 1. So that part you can do by yourself. In the same manner here, Y21 is what? Minus 2 by 11 V1 and Y22 is what? 3 by 11. So in this manner, we can calculate this. Or another way of analyzing this or realizing this is that if you want to calculate Y1 and 11 and Y21, then you have to short circuit the out. Short circuit the output. It means that output is what? V2. You have to make V2 equal to 0. It means what? In this circuit, you have to remove this part. Okay, you have to remove this part. You have to short circuit this. Now you calculate these parameters. Okay. Now you calculate these parameters. So this is how. So when you put V2 equal to 0 here, this is 0, this is 0. So you have only these parameters which we have calculated, y11 and y21. Similarly, for uh, y12 and y22, we have to make your input voltage source 0, or you have to short circuit your input. So when you will do that, you will get your value y12 and y22. So y11 is what? Y12 is what? Minus 2 by 11. Already we have solved. And y22 is what? 3 by 11. Okay. So this is how we can solve this. So this is the way we solved there. Now on the LTSPICE, we'll make this circuit, right? Same circuit on the LTSPICE we can make. I think you know how to draw this circuit on the LTSPICE, so I am not going to tell in detail about this again. So what we will do now, we will analyze this circuit. So we will remove this part and we will short circuit this. Okay. We will short circuit this. So this is your circuit. Now, if you want to calculate the value of y11 or y21, because we have short circuit the output. If you see here, we have short circuited this, right? So you have this circuit. If you want to calculate, so first of all, we will do this theoretically. So this is the current which is coming here. Yeah. This is the voltage. So these two are in parallel, right? So these two are in parallel. So equivalent of this value is how much? This is 1 ohm. And these two are in parallel. So 2 into 3 divided by 3 plus 2. 6 by 5. And you have a voltage source of 5 volt here, right? So this is your I1. This is your, sorry, V1. Okay. So if you want to calculate, V1 is what here? 1 plus 6 by 5 into I1. So this is what? 11 by 5 V1 by I1. And what is your Y11? It is I1 by V1. So that is what? 5 by 11. Okay. 5 by 11. So this is 5 by 11. So this is the mho, because reciprocal of ohms is what? Mho. So you can say that it is reciprocal of, so you can use the word mho. Right. In the same manner here also, if you see, if you know the value of voltage, that is 5 volt, and you know the value of current here in this loop. So what we will do, we will simulate this. Okay. So what I can say that stop time, can it be a transient analysis? Can I use the word transient for this? Should I want this or what I should do? Okay, give here 5 seconds. Let's check, because I need to check whether it is coming out to be great or not. So if you see here, this is the voltage and I want to calculate the value of current. And here, if you see, The value of current is 2.273, in between 2.273 and 2.2725. So half of this will be what? So here experimental results are saying that the value of I1 is 2.7, 2.27. So if you see here, 2725 2725 plus 2.2730 divided by 2. Iska karna, what is the value of this? It will be in between. Okay, you can write the average value also. 2.273. You write the average value, no problem. Na? Means it will be something to 0.275, something like this will come. But you can write it like this. So when you divide, you know the 5 divided by 2.273. What is the value? Do you have scientific calculator with you? एक बार try करो इसके value क्या आ रही है? Okay, I need to do opposite. Sorry. Because it is I by V1, na? I'm doing V1 by I1. No. So you have to divide. I'm calculating the approximate value here. 2.273 divided by 5. So what is the value? This should be equal.
0.4545.
0.45. And what is the value of this?
0.45.
So both are equal, right? Now you need to calculate another parameter. Because we want to calculate what another parameter is y.
22. Oh, wait, y21.
Y12, right? Y21. Okay. So Y21 is what? It is the ratio of the I2 by V1. What is I2 here? The voltage which is coming from this side, but because there is only one source, so this will be negative. So if you see here, that's why here in if you see the negative sign is coming. Where is Y21? That's why because the direction is opposite of the direction of the two-port network mathematics, and the direction which is there, it is opposite. That's why this minus sign is coming. So here also, so if you want to calculate the current in this branch, then if you know the value of voltage here, you can calculate the branch current, right? So the value of voltage is how much? 2.7, 2.727. This value. Okay. What is the value of this value? This is the value 2.727. Voltage is, so here the voltage is, I should write V2 or V3 because otherwise you will get confused. V3 is
2.727.
727. 727. If you know the value of voltage, you can calculate the value of current, right? If you see, if you know the value of voltage here, what is the current? This voltage divided by this 3 ohm, then you will get the current in this branch, right? Because current source is not there, so it is not showing the current value. So what we can do, what is the value of this I2? It will be, I'm using the minus sign because the assumed direction is opposite. So this voltage 2.727 divided by 3. What is the value of this?
0.909.
2.727 divided by 3. 0.909. So this will be your 0.909. Okay, now you got the value with the minus sign, right? So again, here you can check what is the value of this. 2 divided by 11.
Uh,
It is
0.1818.
okay. So okay. Sorry, it is the current value, na? So we got the
Yes.
current value, and what is your y21 parameter? It is the ratio of the I2 divided by the voltage V1, that is 5. So minus 0.909 divided by 5. What is the value?
0.181.
0.909 divided by 5. So the same value is coming, right?
Yes, sir.
It is minus 0.1818. So in this manner, we have verified or we have calculated the value of the y parameters experimentally as well as theoretically. So you can try for y12 and y22 in the same manner. What you have to do? So again, we can do this also, or you can try by yourself because that would be learning for you. So what you will do now,
Short circuit the V1.
you will do, okay, let me cut this. We'll use a voltage source this side. Okay, you connect this. And here you short circuit this. No, sorry. Now you have to do the opposite thing. Understood? At that time, you can take a voltage source. Suppose that you have taken 4-volt source. You take a 4-volt source here and you analyze the same thing which I did earlier, which we did before some time. Okay. Understood?
Yes, sir.
So you can do this, right? And then you verify in the same manner that the value of y12 and y22, they are same. Y12 is again minus 2 by 11, that is minus 0.1818. And y22 will be 3 by 11. So you just in the same manner as we did in the input side or for these y11 and y21 parameter, you can do the same thing for your y12 and y22 parameters. Okay. And you can make a table here that theoretically, as we have calculated here, and measured. Measured bole to practical, or you can use the word practical also, that is more appropriate. You have to write the value of y11 here and y11 dash. I'm writing dash for practical. y12, y21, sorry, y2. In the same manner, y12 dash, y21 dash, and y2 dash. So this is the experiment where we are calculating the parameters and verifying the y parameters. Understood? Augustus?
Yes, sir. Yes, sir.
So I
Yes.
think you can do the same thing in your for the output port also, where you will short circuit the input port and you can calculate the parameter y2 and y2. ठीक? Can we move to the next experiment now?
Yes, sir.
Okay. So experiment number 7 is there. Sorry, 8 is there. Where you have to calculate and verify the ABCD parameters. Okay. So if you remember, what are the ABCD parameters? These are basically used in your transmission, or you can say that power engineering. Okay, power electronics basically. So there we have, suppose that if you have a circuit like this, I can take example. Generally, when you calculate this in maths, okay, I can open a new file, that would be better. So I'm taking I'm taking an example so that you can understand this. Currently, I am using only resistor part, but in your circuit, you can have a inductor and capacitor also instead of this only resistor. Or there can be combination of resistor, inductor, resistor, capacitor in the branch. So that is also one possibility. So you need to take care of that part also. Okay. Now we will connect them. So in this manner, we are connecting them. Now I will use a voltage source at the input side, at the output side. Again, we will connect it. You can use a voltage, any voltage value you can use here. We need to connect this with ground also. Please remember, generally people do this mistake. So we will connect one ground here. You can give the values here. So now I am taking this value as 30 ohm. This value is 40 ohm. And this value is 50 ohm. Okay. These are the sources. If you go in the theory of ABCD parameters, let me help you in remembering that. So these are the parameters where we are calculating the input voltages and current with respect to output voltage and current. If you see here, input voltage and current is there. We are calculating with respect to output voltage and current. Okay. So in this circuit, your ABCD parameter, you have like I1. So you are using V1 or I1? V1, I1. This is A, B, C, D. And we are calculating with respect to what is the values? V2 minus I2. Okay. So here it is V2 minus I2. Okay. So if you simplify this, you will get a value of V is what? AV2 plus V minus of I2. Similarly, your I1 is what? CV2 plus D minus of I2. So if you see from a network point of view, the network equation which I have taken, the network, if you see here in this schematic, okay, this is the network which I have taken. If you see, you have the input. Let me draw the circuit here also. So I have taken this simple circuit. You have a 30 ohm resistance here, 40 ohm resistance here, 30 ohm resistance here. You have a voltage source, and this is connected to ground. Okay, you have a voltage. You can say that it is 5 volt. That is equal to V1, and V2 is equal to 4 volt. This is I1. This is I2. If you see, if you want to calculate these parameters, you have to look from the input output side only. If you want to calculate A and C parameter, you have to short circuit the output. So when V2 equal to 0, you will get what? B. And B is what? V1 minus of V1 by I1. D is what? Minus of I1 by I2. Okay, sorry, V1 by I2. This is I2. Okay, so this is the parameter. Similarly, when what we are doing here, we are short circuiting the output. Similarly here, I2 equal to 0. So what we are doing, we are open circuiting the output.
Open circuit.
Okay, we are we have open circuit the output. So as a result, what is happening? We are only playing with the output port. We are not doing anything at the input. So here your A parameter is what? It is V1 by V2. C parameter is what? It is
I1 by V2.
I1 by V2. Okay, so these parameters we do. We can calculate it like this. So what we will do here in the circuit on the LTSPICE, once we will short circuit this, then we open circuit this. Okay, so again we will do the same thing. So first of all, we will short circuit this. Okay, I need to define the value. Suppose that I have taken 5 volt. So if you see, I am doing the DC analysis of the two-port network. If you see, I am taking a DC source, I'm taking register values. But if you want to do the AC analysis, what we will do? So for that, I will have a separate session, maybe next week, where we will do the AC analysis. If you have a AC source, how you calculate these parameters. I will take some more resistor, inductor, resistor, capacitor also as part of your circuit, because in AC you have all these as part of your circuit. So there is a direct .NET method, means netlist method, which we will use to analyze these parameters. LTSPICE can directly calculate those parameters. It has that inbuilt capability. So we will use that also. Okay.
Okay,
So
sir.
currently I'm doing we are solving very simple circuits, but we can go in the complex side also. So that is by the help of netlist. So here what we will do, if you see in the calculation values here, when you are short circuiting the output, what is your B? It is V1 by I2, right? So first of all, you should know the value of V1. So V1 is what here? 5 volt. So in this circuit, if you see here after short circuiting, after short circuiting, after short circuit the output, your V1 is 5 volt. And what the other parameter which you need? We need what? It is, if you see here, we want to calculate B and D. So what is your B? It is V1 by I2. What is your D? It is minus of I1 by I2. Right. So if you see here, V1 we know we need to calculate the value of I1 and I2. Right. So I1 also we can calculate here. When we go in the simulation mode, directly I am writing 5 seconds. Okay. Okay, now I want to calculate current in this, because I1 is very important, right? The value of current is 95.7 milliampere. So I1 is what? 95.7 milliampere. Okay. So I1 you know. So what is the value of B? V1 by I2. V1 is what? 5 divided by 95.7 into 10 raised to power minus 3. What is the value of this? It
सर
is
हमने तो I1
5000.
कैलकुलेट किया.
क्या आया इसका वैल्यू? Am I right? Okay,
I1 कैलकुलेट
sorry.
किया ना मैं
Yeah,
चाहता
I
हूँ
did mistake.
I2.
Sorry. We need to calculate the value of I2 for this. So this is I1. So we will calculate the I2 now. If you see in this case, in the circuit, I2 is what? If you know the value, okay, we can calculate directly also. That's good. So the value of this is directly we can calculate, and this is coming out to be minus 42.55 milliampere. So your I2 is what? I'm writing only magnitude part. It is 42.55. 42.55 milliampere. So you have to divide this 42.55. The sign part will take care later on, na? That we can do. So if you see here, this value will be what? V1 by 42.5 into 10 raised to the power 3. So 42.55. What is the value?
117.5.
5000 divided by 42. 117.5. Yes. So this will be 1117.5. So this is your impedance parameter. So you can say use the word ohms here. Okay. In the same manner, D is what? Minus of I1 by I2. So I1 is what? 95.7. I2 is what? 42.55. What is the value? 2.25, right? यही आएगा ना? आप क्रॉस चेक करिए, मैं भी कर रहा हूँ, आप भी करो. अगस्तस्य.
Yes sir, यही आया है.
Okay. So this is the parameter we have calculated by using the experimental simulation. है ना? Now we will try to calculate the same parameter by mathematics. Okay. So generally when you have this kind of circuit, then the easy method is first of all you calculate the Z parameters. Okay. So first of all we will calculate the Z parameters, and we will use the formula of calculating the ABCD parameter from Z parameters, right? So when you will solve this, you can write this in terms of these parameters like V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to what? Z21 I1 plus Z22 I2. So when you calculate Z11 value, I'm writing directly so that Z11 value is 70 ohms here. Z12 is 40 ohm. Z21 is 40 ohm and Z22 is 70. Okay. Now we will calculate the ABCD parameters from this. So if you will calculate ABCD parameters, then the formula I'm writing directly Z11 divided by Z21. So what is the value Z11? 70 divided by Z21, 40. This value is coming out to be 1.75. What is our value of, okay, we have not calculated A till now. Okay. Similarly, your B is what? The formula I'm writing. It is Z11 into Z22 minus Z12 into Z21 divide by Z21. This value will come out to be 82.5. We got similar value or not? There is a difference. Okay, I'll check the formula then. There should not be difference. Similarly, D is what?
Right.
C for C formula, you have 1 by Z21. You check whether it is accurate or not. Are we doing any mistake? And for D, it is Z22 by, because the difference is somewhat bigger, not small. It is 70 divided by 40, 1.75. It is A and D is near to 1.75, but our value is coming out to be 2.25. Am I doing any mistake? Let's check the circuit again. This is the value. Minus 95.7. You know, this is 5 volt. 30 volt. Oh, I have taken the value for 50 here. That is the result. Okay. That is the reason. The value, okay. I'm taking 50 and there in the calculation I was writing for 30 here. So I need to make it 30 also. Then it will come. This was the mistake. This was 30. Okay. Now we will simulate this. Okay. So if you go here, this value is, this current is this one and the value is minus 106.1. So I1 is how much? So in this case, your I1 is 106.1, right?
Yes,
0.06 लिख देते हैं ताकि क्लोज ही आ जाए ये वैल्यू 0.6. I2 we need to calculate. This value of I2 we need to check
I2
from
I2 भी वहाँ उसी से कैलकुलेट हो
huh? This is minus 60.61. 60.61 milliampere. Now we do the division and all this stuff again. Okay.
83.2.
If you see, it is I2. So when you divide this by 1, I2 is 60.61 milliampere. So it is 10 raised to the power 3. 60.61. What is the value?
82.5.
Divide by 60.61. 82.5. Same, right?
Yes, sir.
82.5. And D is what? I1 by I2. 106.06 divided by 60.61.
1.75.
Divided by 16.61. So this is 1.75. Similarly, you can calculate A and C parameters because means you have to open circuit the output and then you can calculate. So those values will also come out to be. So if you see here, we are able to obtain the same theoretical and experimental readings. Okay. So I think now you can calculate the Y parameters and ABCD parameters using LTSPICE and mathematically also. You understood this concept?
Yes, sir.
चलिए ठीक है. So thank you for today.
Thank you, sir.
Anything else you want to